Hey guys, hope everybody's doing okay. What we're going to do is take a look at a couple pages in our packet titled Compound Mixture or Element. And these pages give you various scenarios. There are 7 of them. And you're going to read through this scenario and figure out is the item they're describing an element, compound, or a mixture based on what we know from Unit 1. This is a great review of a lot of the concepts from throughout the unit, from element, compound, mixture, all the way up through physical, chemical changes and methods of separation. So I'll walk through the first one with you, and you guys will work on the rest of them, and we'll go over them in class, or I'll have the answer key posted. So let's take a look at them. The first one says it's a colorless homogeneous substance that's liquid at room temperature heated up in a beaker. So I like to go sentence by sentence and figure out, can I eliminate anything after each sentence or have a better idea of what it is after each sentence. So this is important that it's a liquid at room temperature. I'm going to start with elements, okay? Elements that are liquids at room temperature are few and far between. There are only 2 of them. And I might have mentioned them in class. If not, I'll mention them here for you. The only 2 liquids at room temperature that are elements are mercury. And mercury, it's not red or blue like you might think from looking at a thermometer. Those are the newer thermometers. If you look at an old mercury thermometer, it is like a silver gray color. Okay, so this cannot be mercury because it's not colorless. And the only other liquid at room temperature that's an element is bromine. And bromine is a deep, deep red color, which is also not colorless. So it cannot be an element. Okay, there are no other liquid elements at room temperature. So can't be that. If you look at the periodic table in my room on the wall, the liquid elements at room temperature are in blue font, the gases are in red, and the solids are in black, which is most of the periodic table. Okay, so it can't be an element. We know that right after that first sentence. So let's, I should have the answer, it's popping up here. Let's write that in. Okay, so take a second and jot that down. This is what I would do. I would write element compound mixture and say what's what. So it can't be an element because the only liquid elements at room temperature are bromine, which is red, and mercury, which is silver or gray. Okay, let's go on. Next sentence, the liquid starts to bubble and the amount of liquid diminishes. So what's really happening here? We have some evaporation occurring, okay? So, think of a colorless homogeneous substance. So that's not an element. So it might be like rubbing alcohol, that's a compound. It might be salt water or sugar water, that's a mixture. For both of those, the liquid will start to bubble and the amount of liquid will diminish. Well, that doesn't narrow anything down for me. So it could still be either a compound or a mixture after that sentence. All right. Want to go. After 20 minutes, the beaker is empty and perfectly clean. So all the liquid's gone and it's perfectly clean. This part here is really important. Okay. Think about it. If you had a mixture, say this was salt water or sugar water, and you separated it based on this method of separation, this heating method, so it's basically crystallization, you should have something left over at the end, right? Well, we didn't. So whatever was in that beaker is all into the atmosphere now, into the air. So it can't be a mixture because there should be something left over when all is said and done. So it can't be a mixture because after heating, you would have your solute left over in the beaker. This example has the beaker remaining clean after heating. Okay, so it can't be a mixture here. If something was left over, like a white crystal substance, then yes, it would be a mixture because there was something left over. And another way to explain it would be crystallization is a physical method of separation. So if it was separated physically, the physical methods of separation only separate mixtures, which would mean this had to be the answer, right? But it didn't work, right? It didn't separate it physically at all in terms of crystallization, right? You didn't have anything left over. So it couldn't be a mixture in terms of salt water or sugar water or some other solvent or solute dissolved in a solvent. So what could it be? Well, obviously it's a compound. Let's think of how we could explain that. After 20 minutes, the beaker is entirely empty and perfectly clean. All we really had here occurring was evaporation, right? The liquid evaporated and went from a liquid to a gas. So you didn't really separate the compound, right? The only way to separate the compound is to do electrolysis, right? We talked about that with methods of separation. So you didn't separate it at all. All you had here was a phase change for your compound. So let's see how we can explain that. All we had was a phase change. Phase changes are physical changes. That's from a couple lessons ago, or earlier in the unit. So there was no change to the chemical composition of the substance. That is important. All right, if there's no change to the chemical composition, then it's just a physical change, okay? So we had a liquid compound going into a gas compound. This is very similar to what we had in the chemical physical changes lab with the periodic chlorobenzene, but that was a solid to a liquid and back to a solid again. Okay, so we heated it, it cooled, it refroze, and that was all we had. Here we're heating it, we're basically boiling it, evaporating it, and it's in the air now. All right, so it has to be a compound. Because it obviously can't be an element because of the colors. Can't be a mixture because nothing was separated. So that helps us identify what it was here. We tried this like physical method of separation and it didn't work. The compound remained in the compound form. It just was a different state of matter, liquid to gas. All right, that's really about it, guys. If you scroll through the rest of these, you can use your notes. You have some of these pictures similar to this earlier in your packet. 3 isn't too bad. It can be a little tricky, so there's a lot of information missing in number 3. So figure out what you're missing. It might be easier to answer that one that way. Don't think too much into number 3. 4, you guys shouldn't have too much of an issue with. It's talking about a method of separation here, mentioned in that sentence. Scenario 5 has 2 parts. It's usually pretty good for part A. For part B, use your book, page 50. We also did something exactly like this earlier in your packet for some homework. 6, you did this in the chemical physical changes lab. Think if you could recognize this scenario. You probably will be able to, and it'll help you identify what it is. And 7, a good way to do this is to do a Venn diagram. We should have done an example similar to this with iron and sulfur and iron sulfide in class. That's it, guys. So knock them out. Take some time on it. Do what I did here, and have element compound mixture, why it can or can't be those. It'll be a really, really good review for you going forward. Okay, that's it, guys. See you later.